Welcome to Level Up Mathematics, Day 3 of the Math Bootcamp. I'm Alejandra, the founder of Level Up Mathematics, and I'm here to guide you through your third day, the radical exponents. What are exponents? Exponents show repeated multiplication. This only works with the same number. So if you have 5 times 5, you would say 5 to the second power, or 5 squared. Now there's two ways to write out exponents. You can have the number, the up arrow, and then the exponent number. Or, as you can see on this slide, you can have a small number right next to it. It's at the very top right corner. If you have 2 times 2 times 2, then you would say 2 to the third power, or 2 cubed. 7 times 7 times 7 times 7, since there's 4 sevens, you'd say 7 to the fourth power. Here are more examples of exponents. So 3 times 3, since there's 2 3's, would be 3 to the second power. 3 times 3 times 3, since there are 3 3's, you would say 3 to the third power, and so on. Next is 4 3's, then 5 3's, then 6 3's, and then 7 3's. This can go on for infinity. Here's the vocab. The main number that is actually being repeated is called the base. The little number to the top of it that shows you how many times it's being repeated is called the exponent. And then together, they're called the power. Properties. The zero property. We're going to use b as a theoretical number. So b could stand for everything. The reason we're using b is because b stands for base. As you can see in the previous slide, that's this number right here, the base. Zero property. Any number to the power of 0 will always equal 1. So 8 to the power of 0 equals 1. 2 to the power of 0 equals 1. 10,000 to the power of 0 equals 1. Any number to the power of 0 equals 1. The exponent 1. Any number to the power of 1 does not change. 4 to the power of 1 equals 4. 3 to the power of 1 equals 3. 900 to the power of 1 equals 900. As you can see previously, if we got rid of this 3, then it would be 3 to the 1 power. And since there's only one 3, 3 equals 3. Next is the negative exponent. If b is raised to the power of any negative number, and we're using x to represent a different number here. So if b to the power of negative any number, so b to the power of negative x equals 1 divided by b to the positive x. So for example, 5 to the negative 2 equals 1 divided by 5 to the 2, which equals 1 divided by 25. Multiplication. b to the power of m multiplied by b to the power of n, and we're using m and n to represent any numbers, equals b to the power of m plus n. So if we have 5 to the power of 2 times 5 to the power of 1, as long as the base is the same, then we have 5 to the power of 2 plus 1 equals 5 to the power of 3, which equals 125. Division. b to the power of m divided by b to the power of n equals b to the power of m minus n. So this is an opposite of the multiplication one, which instead of having it being multiplied and added, it's divided and subtracted. So an example of this is 4 to the power of 3 divided by 4 to the power of 2. This would equal 4 to the power of 3 minus 2, which equals 4 to the power of 1, which equals 4. Exponent of an exponent. Now let's say we have in parentheses b to the power of m, and we take that and put that to the power of n. That would equal b to the power of m times n. Now in this example, m and n are right next to each other, and that represents multiplication. You'll be seeing this a lot in mathematical equations where they're not actually normal numbers. So an example of this is 2 to the power of 2, and then take that equation to the power of 2. And then a simple way of putting it is 2 to the power of 2 times 2, which equals 2 to the power of 4, which equals 16. Then we have power of multiplication. So we have in parentheses a times b, and then we take that equation to the power of m. That equals a to the power of m times b to the power of m. So an example is 5 to the power of 1 times 10 to the power of 1. And once again, this only works if m is the same number. So 5 to the power of 1 times 10 to the power of 1 equals 5 times 10 to the power of 1, which equals 50 to the power of 1, which then equals 50. Power of division. This is the same, except instead of multiplying, it's dividing. So a divided by b to the power of m equals a to the power of m divided by b to the power of m. An example is 10 to the power of 2 divided by 5 to the power of 2 equals 10 divided by 5 to the power of 2 equaling 2 to the power of 2, which equals 4. So remember how multiplication is the opposite of division? Well, exponents are the opposite of a thing called radicals. So when you have 4 to the power of 2 equals 16, the opposite of that would be the square root of 16 equals 4. Vocab. The number that's in between the little space of this radical symbol is called the index. In this equation, it's 3. The number inside of the little bracket, it does look like a division symbol, but it's not a division symbol. It's called the radical symbol. So the digit inside of the radical symbol is called the radicand. And the entire thing is called the radical. Definitions. As you can see on this previous one, I called this the square root, but there's no number on the outside. That's because it is most commonly supposed to be a 2. However, since it's so common, you don't have to bother writing the 2. If you do not write a number on the outside, everybody will assume you just mean 2. So, the radical symbol with an index of 2 equals the same thing as if there was no index. And this equals x to the power of 2. Then an index of 3 equals an exponent of 3. An index of 4 equals an exponent of 4. So the number that is the exponent should be the same as the number that's in the index. Properties. The x root of a to the power of x equals a. So for example, if you have the square root of 9, but then you raise it to the power of 2, then you just get rid of the radical symbol and it equals 9. This is because the index and the exponent will cancel out. This only works if they are the same number. Another example is the cubed root, and that is what you call it when there's a 3. A cubed root of 10 to the power of 3 equals 10, because the index and the exponent cancel out. Next, we have the x root of a to the power of x equals a. So if you have the square root of 9 to the second power, that will equal 9, because once again, the index and the exponent cancel out. If you have the cubed root of 10 to the third, it will equal 10, because the index and the exponent cancel out. The x root of a times the x root of b will equal the x root of a times b. This only works if the index is the same in every number. So, the square root of 2 times the square root of 5 equals the square root of 2 times 5, which equals the square root of 10. The cubed root of 4 times the cubed root of 2 equals the cubed root of 4 times 2, equaling the cubed root of 8. Simplifying. You can simplify these radicals to get smaller numbers, which might be easier to work with. So let's use the numbers 16 and 3. 16 times 3 equals 48. And we know that, based off this one, that A times B will equal A times B. Based off this property, we know that the x root of A times the x root of B equals the x root of A times B, which you can see here. Now, we know that 4 times 4 equals 16. So we can simplify the square root of 16 to just 4. So 4 times the square root of 3, which we can simplify to just put the 4 by the side of the square root of 3. So as we can see, 4 times the square root of 3 will equal the square root of 48. Adding. Now, since we know we can have a number on the outside of this symbol, there would be equations with it. So 10 times the square root of 3 plus 2 times the square root of 3 will equal 12 times the square root of 3. This only works if the number in the square root is the same. If it's the same, then you can add the numbers on the outside. The same works with subtracting. 18 times the square root of 5 minus 10 times the square root of 5 will equal 8 times the square root of 5. This only works if the radical is the same number. Thank you for attending. Please check the description for the Radical Exponents Bootcamp materials. If you want to see more videos like this, please hit that like button and subscribe for more content. Please follow our social media pages, Level Up Mathematics, to gain access to more material just like this. If you want to join our Math Bootcamp, please check the materials that are in the description and complete all our daily lessons to earn your certificate of completion. Thank you so much for watching. Have a pleasant day.